All right, so now this is the code. I'm gonna trace both test cases. I'll trace the non-empty array input, the non-empty input array case first, and then I'll trace the empty array input case. Here you can see we got two test method for the JUnits, which will call the same get intermediate sums utility method. Right? Let's now trace the first one here. So let's say we want to do test one over here, which is going to call get intermediate sums over here. All right. Let's see what's going to happen here. What's going to happen is we got input over here. Input is an array over here, and I'm not going to visualize the array using the memory model like this anymore, right? It's kind of it's nice to draw if you wish, but but to save time and to be more effective on tracing, I'm going to use the abstract diagram which I showed to you before. This one, that's the diagram mechanism I'm going to stick to for the rest of the semester. So now we got input over here, so which means input is actually going to point to an array of how many elements? 1, 2, 3, 4. So now let's have an array of 4 elements inside. Okay, we got 1, 2, 3, and 4 indices 0, 1, 2, 3. And then I'm going to put the elements, it's going to be 2, 3, 4, 5. So 2, 3, 4, and 5. So that's the input. Okay, what about expected? Expected is going to be just another array of size also 4. Okay, so I'm going to put expected over here. So expected, which will be for comparison later. Okay, it's going to be just another array over here, also of size 4. 0, 1, 2, 3 indices, and the element will be 2, 5, 9, 14. 2, 5, 9, 14. So try to get used to how to draw arrays in order for code tracing. It's going to be very necessary later on if you want to analyze the behavior of your code, if they got any issues. Okay, and then we're going to execute this line here. Okay, this line here, we're going to call the get intermediate sums over here, and then we're going to pass the input. Agree? We're going to, and then later I'm going to compare expected versus result in a moment. We'll do that. Okay, so what we'll do now is we're going to trace the input here. So you can see here, every occurrence of ns is going to be replaced by input. Every occurrence. Okay, and then we're going to have ns over here is going to be input. And also anything else. Okay, ns over here is also going to be input. So we are really talking about this particular input array for this particular method call. All right, and I think this one should also be input. Okay, I don't think I missed anything. Okay, so that's good. Let's now trace inside this utility method, like a step into. The first line here, we are simply creating another array over here, result. Okay, you can think about result, I'll put it here. Result is simply pointing to null. When I say null, you can think about it's simply just nothing. Let me just don't put anything here. It's simply arrow is pointing to nowhere. Okay, and then we're going to have a variable here called sum. So I'm going to put a variable over here. So that's sum. Initially, simply just 0. Okay, and then we got another array over here, sums, and then I'm going to put it here. And the sums array is going to be a new array of what size? The size is going to be input length. What's input length? Input length is going to be basically a maximum index plus 1, right? So it's going to be 4. So that means the sums is also going to be an array of size 4. However, one thing to note, okay, let me put it down. 0, 1, 2, and 3. However, remember using this particular notation, we know that every element is going to be of the default value for integer. So it's going to be 0, 0, 0, and 0. That's what's going to happen after this line. And then we're going to start a loop over here, for loop. And you can see initially I is simply just going to be 0. Okay, let me also put I here. Okay, I initially is simply going to be 0. And then I will, as long as I is strictly less than input length. So input length, as we know, is actually simply equal to 4. So now let's predict how many iterations are we going to get. We're going to get into the first iteration when I is equal to 0. Second iteration when I is equal to 1. Third iteration when I is equal to 2, and fourth iteration when I is equal to 3. And then when I is incremented to 4, Do we go for the 5th iteration? We don't, because 4 less than 4 is going to be false. Right? I'm just mentioning that verbally, so hopefully you're okay with this tracing here. Right? So for now, I'm going to assume that you already know how to trace the for loop, so I don't need to waste too much time for you. All right, and then we're going to make sure we also always do I++. Now, for iteration number 1. For iteration number 1, the sum is going, the I is going to be 0 over here, right? For iteration number 1. So sum is going to be incremented by input at position 0, at index 0. That's going to be this value over here. So sum plus 0 plus 2 is going to be 2. And then, so here we say sum at index 0 is assigned to this sum value over here. So sums at index 0 is assigned to just 2. So that's what's going to happen in the first iteration. Okay. What about the second iteration? For the second iteration, I'm going to use another color. For the second iteration, I is going to be incremented by 1. So that'll be from 0 to 1. So we're still going to go into the body of the loop, and then sum will be incremented by input at index 1. In this case, index 1 for the input will be 3. So 2 incremented by 3 will be 5, right? And then sums at position I, in this case I will be 1, right? And then should be assigned to the sum, which is 5. So that means at index 1 is going to be 5. All right, guys, hopefully so far you're okay with the tracing. Okay, and then we're gonna just, for completeness, let me just continue. What about the third iteration? For the third iteration, let me go a little bit quicker. For the third iteration, because i's value is going to be 2, so that means we're going to assign index 2 for the input array 4, and then plus that into the sum, which will be from 5 to 9, right? And then we're going to assign this particular sum over here into sum at position 2. Okay, so that means this value over here is going to be 9 over here, right? We're missing one more iteration. Let's do one more. Let me use purple. Okay, we're gonna go into the loop for the fourth iteration, and now i's value of course would have been incremented to 3 already, right? So in the previous one it should be 0, 1, 2, right? It will be incremented to 3 in this case, right? You can see many things are happening right now, so I kind of assume you already know how to trace a for loop, so it's really important. Otherwise, you may want to seek for help from me, so I can go over even more detail with you. But for now, we should be okay. All right, for the last iteration, I will be equal to 3, and then we're going to say sum plus equal input at index 3. Index 3 over here is going to be 5, right? So 9 plus 5 is going to be 14. That's what we're gonna get. And when you get to this line over here, sum at position 3 assigned to the current value of sum, which is 14. So that'll be 14 over here. And then after this, I would have been incremented from 3 to 4. And now, if you got, remember I less than input dot length, right? In this case, ns will be input. Input dot length. Okay. If you try to do this, it's going to be I will be 4 less than 4. So that's going to be false, which means we're going to exit from the loop. So once we exit from the loop, so you can see the sums array looks very promising. That should be the one to be returned, right? However, currently we're returning the result. So that's why this is really important for me to show you this line over here. Look at this line here. When I say result is assigned to sums, so this is what I said verbally before. Let me just mention again. Think about sums at the moment is storing the base the starting address for this particular array. We want to copy this address into the result, so that result is also pointing to the same array. It's something called aliasing, which we'll definitely speak more formally about when we get to objects. But for now, all you need to know is every array variable stores the starting address of the array, and this address may be copied over to other variable. For example, we copy this address over here into result. The consequence of that is result will also be pointing to the same array. We are not creating any new array. We are not. We're just copying the address over. That's something you want to understand. All right. So what's gonna do? This line here? So result, rather than being null, is now going to point to just the same array over here. Okay, it's going to be, and then we're gonna return the result. Okay, so once we return the result, it's going to be stored into this particular result. I just choose the same name. So you can think about, so now the result, you can think about in different scope, there is just another result variable over here, and then also pointing to the same array. So what we should really compare would be, let me just highlight it. We're gonna compare result and also expected. Think about, we're gonna compare the contents of this array. Let me just say this. We're gonna compare the contents of this particular array that's pointed to by the result, and also the expected array over here, right? That's exactly what this line is doing. And then, are these two arrays the same? Well, absolutely. 2, 2, 5, 5, 9, 9, 14, and 14. So this is something that assert array equals will do for you. Okay, you only say assert array equals when both arguments over here are actually arrays. Okay, one is the expected one, the other one is a actual one, the return the return value. All right, so that's about very detailed tracing for this particular case. Let's do very quickly about the second one. The second one is rather easy. Okay, let me do just start a clean page and do the second one. Okay, so the same code over here, but now we are talking about the second test case, the second test method, test number 2. All right, it's also going to call this particular method over here. All right, and this one here is also very interesting because it's like a simple case, but importance boundary case. So we got input over here is going to be empty array. You can think about the way to visualize this is it's really pointing to an array that does have some starting address. However, the array is simply just empty. Notice that here, this is how I draw the empty array. On the other hand, if the array simply the array variable simply stores null, in that case, I would say input arrow over here. So this will be referring to null. It's not really even pointing to empty array. All right, just notice the difference. And the expected array is also empty. So I'll put it here. Expected array is also empty over here, nothing there. We're going to pass the input to the method. So now every occurrence of ns is going to be input. Okay, just remember that. So which means ns over here, ns and ns, they will all be referring to this particular input array. Let's see what's going to happen over here. We're going to execute line by line. Line number 1, we're going to say result is let me just use a pink. So line number 1, result is going to point to just null, nothing. And then the sum is just going to be 0. I'll leave, okay, I'll just put it here. Okay, sum is going to be 0. And then over here, what kind of array are we creating? Well, just follow this. Input array length will just be 0, right? It's going to give you 0. Meaning that you're going to create an array of size 0, which will be empty array. So we're going to create sums over here. It's just going to be an empty array. Notice the difference here. Result is null. Sums over here is empty array. So you can see the notational difference over here. That's important. Being null is completely different from being empty. They're different. Let's now see how we can execute this for loop over here. Of course, the most important condition to check would be I strictly less than ns the length. In this case, input the length. And we know that I has been initialized to be 0. So 0 less than, what's input the length? Input the length would just be 0. 0.0 is going to give you false, meaning that we're going to completely bypass the very first iteration. We do not even enter the loop. Remember what I mentioned to you before? So for the for loop, it doesn't necessarily you have to enter to execute the body of the loop for the very first time. So this is one case, right? So that's okay because for some boundary cases for your utility method that uses array, in that case, if the input is simply just empty array, in that case you just don't need the body of the loop to really complete the job. Okay, it's completely bypassed. So the next line we will do is outside the loop. So we're going to say result is simply reassigned to sums. So result, rather than storing null, is going to store the beginning address of the sums array. So that means result is simply just going to be empty, right? And then we're going to return the result. And when we say return the result, So that means this particular value over here, the return value, is really this particular result over here. And then I'm going to store the result into just the same variable name in a different context. So scope-wise, they are fine, right? There's no clash because they come from different classes. Java compiler will be able to tell, but you don't have to worry, okay? So the result over here, let me just be explicit over here. You can think about result over here is just another result from another scope. It's really referring to this empty array. So now what are we comparing? We are really comparing expected and also result. Expected is empty array, and also result over here is also pointing to empty array. Are they the same? Yes, empty array is just the same as empty array. So that's why this will pass. All right. Finally, I would like to show to you how you can use the debugger to really debug this kind of array utility method. Okay, it will be very important for you to know. Let me now be very deliberate about what I want to show you. Okay, let me show you one thing first. It's really important when you do your labs, when you're doing your programming test number 2, or maybe later test, when we have to test you about arrays in the utility method. Let's say somehow the test failed. What are you supposed to do in order to debug the error? That's the most important thing I want to tell you. Okay, what I will do is I'm going to create some some error over here in my excuse me. I'm going to create an error in my code over here. Let's say I forgot to actually say plus equal over here. Let's say I forgot. This is correct implementation. Let me give you something that's wrong. Sum is simply equal to ns at position I. So there is no intermediate accumulation. Okay, this is wrong. Let's say, and apparently, if I rerun the test, I'm gonna see one failure, especially for test number 1. For test number 2, that's okay. Remember, for test number 2, it's simply just going to return an empty array anyway, so the body of the loop being incorrect is not relevant. Okay, but we're still failing one test. So that's exactly what I want to show you, how you're supposed to look at and try to do something about it. All right, so now we got some wrong implementation in our array utility class, right? And then I would say it's a couple of places you should really go to. Number one, to see you might have more than one tests failing, go to one of them. For example, this one, test 1. Double click on that. So it shows to you exactly this particular test is failing, this assertion over here, assert array equals. And then you can see over here, under failure trace, you will see array first different at element 1 and also expected 5, but 3. What this is saying is, the expected and also result array, they are different. That's why you failed the assertion. And the very first occurrence where they're different is at index 1. At index 1 over there, in expected is actually 5. In expected in the result is actually 3. I would say this may not be so friendly for you to look at. So that's why I want to show you how useful debugger can be in this case. Let's say you know that this assertion actually failed. All you gotta do is put a breakpoint in line number 16. So right before we try to do the assertion, right before we fail, basically. Okay, and then you're going to debug the test, and then you're gonna say right click on test array utilities. You will say debug as JUnit test, and then I'm gonna say switch. All right, so now you can see line number 16 over here, right? So now this will be the critical part, right? You can see we got all the variables. We got input, we got expected, we got result. The input over here, not surprising, is 2, 3, 4, 5. 2, 3, 4, 5. And for the expected, is actually 2, 5, 9, 14. 2, 5, 9, 14. What about the actual array that's returned by your method? In that case, if you look at the result over here, is 2, 3, 4, 5, right? If you look at these two, let me try to put them in parallel. Let me first of all remove all the previous expression over here. So what I would do is I'm going to put, let's say, the expected array over here, and also I'm going to put the the result array. Right? These are the two we're comparing each other. Now, if you expand these over here, you can see the first elements of them are the same, But you can see the second element in index 1. That's where they're different. So this is exactly what a JUnit test was showing to you, right? You can rewind back to what I just said. At index 1, in the expected is actually 5. At index 1, in the result is actually 3. 5 is not equal to 3. So that's why these two arrays are different. But I would say if you use a debugger and pause over here, it's much easier for you to see exactly how the two arrays will look like. And that might just give you some idea about what may have gone wrong in your code. Because in this case, you can see the result is simply just the original array over here. 2, 3, 4, 5. Whatever the input it was, it simply just give you back as the output. So there's definitely something wrong. There's no accumulation in the method. Let me just show you one more thing. Okay, hopefully you got this point. The point I just tried to show you is you definitely want to go to, let me stop this and I'll recap very quickly. So when if you go back to Java perspective, so Eclipse, right? Let me just say this. Let me stop and then let me rerun. Whatever test you actually fail, if the test involves array, they will show you the very first occurrence where the error is, so you can see something from here. If you're able to tell what the mistake is, good for you. You don't need to go any further. Otherwise, I would suggest put a breakpoint on the test that actually failed right before the assertion over here. And then you run the debugger and pause over there and use the variables and the expressions panel to find out exactly where the discrepancy is, where the difference is. Okay, I want to do one more thing before I end the video. So now let's say we understand somehow the accumulation didn't occur. That's what we just saw. So now you can remove that breakpoint. And why don't we simply put a breakpoint exactly line 15 right before we actually call this method here, so we can step into. All right, let's try. So I'm gonna run the debugger again. Okay, let's switch to debug perspective, and then you can see over here we got. Let me go back to variables here. Let's make sure we got the context right. We got input, we got expected, right? Input and expected. So for result, we haven't got anything yet because it's right before executing this line. So what we want to do is we want to step into, right? As soon as I say step into, I'm gonna see the ns over there, right? Remember, in the method, what we have is ns over here. Ns is going to be replaced by the input, which will be in this case this input 2, 3, 4, 5. Okay, just to remind you. Let me now step into. If I step into over here, so now we are switching the context into this particular utility method we are calling. And if you look at ns, exactly 2, 3, 4, 5, right? And then I would say we already showed to you this week about how you can trace the while loop, and tracing the for loop would just be the same. Okay, I'm not gonna waste your time. I just want to show you one thing very quickly. Okay, if I say step over, you can see now. If you see under variables, so you can say result is simply just null. It's basically an array that stores the base address being null, just nothing. All right. Let's say I really want to skip the loop. I want to just go to over here, for example. How can I do that, right? I also show you how you can put a breakpoint over here and then put some conditional, right? That's what I said in the previous video. You can review it. I put a breakpoint over here, and then if I simply say step return over here, and then I can jump all the way here, skipping all those iterations for the loop if I wish. And now you can see result is going to be assigned to sums. You can see result at the moment is still null. What about the sums? Sums over here is actually 2, 3, 4, 5. So now as soon as I say step over, I'm going to get result and sum. Result and sum over here, they are actually of the same array. 2, 3, 4, 5, and also 2, 3, 4, 5, right? That's something to double check, right? You can also expand this to really make sure they are really there. All right. All right, guys, I hope that really makes sense to you, and then you should really keep using debugger. And now I kind of show you the extended feature you will need to pay attention to when your utility method actually got arrays and loops. That makes things a little bit more complicated, but the principle will be the same. You want to use step over, step into, and also step out. All right, so that will be about it for this week. We introduce to you the features of basic array syntax, and also we do one example in thorough detail. I think you'll be ready now to really tackle your labs, and also to go on to do more exercises that I assign to you.